Ever wondered how a computer system works? It's not as mysterious as it might seem. At its core, a computer system is composed of several key elements that work together to process information and perform tasks. First, there's the hardware, the tangible components that you can touch and see. This includes things like the monitor, keyboard, mouse, speakers, and printer. These are the physical parts that make up the machine. Next, we have the software, a collection of programs that tell the hardware what to do. Examples of software include Microsoft Word, PowerPoint, Excel, and so many more. Then there's the data, the information that the computer processes. This could be images, text, video, and a whole host of other formats. And let's not forget about the human element, the people who use the computer to create better products and services. Prepare to dive into the fascinating world of computer systems. Imagine trying to build a house without any bricks or cement. Impossible, right? That's exactly what hardware is to a computer system. It's the tangible physical parts that you can touch, see, and sometimes hear. These are the bricks and cement that make up the foundation of our digital homes. Now let's delve into some examples of hardware. At the heart of every computer is the Central Processing Unit, or CPU. This is the brain of the computer where all the calculations and processing happens. It's what allows you to execute commands, run programs, and essentially do anything on your computer. Then we have the memory, also known as RAM, or random access memory. This is the computer's short-term memory where it temporarily stores data that it's currently working on. Think of it as your desk space. The bigger your desk, the more papers and projects you can have open at once. Similarly, the more RAM your computer has, the more tasks it can handle simultaneously. Next up, we have the storage devices like the hard disk drive or solid-state drive. These are the computer's long-term memory, where it stores data permanently, or at least until you decide to delete it. This is like your filing cabinet, where you keep all your completed projects and important documents. Last, but certainly not least, we have the input and output devices. These are things like your keyboard, mouse, monitor, and printer. They allow you to interact with your computer, giving it commands, input, and receiving information back, output. And those are just the basics. There's a whole world of hardware out there, from graphics cards that enhance video gameplay to network cards that connect computers to the internet. Each piece of hardware has a unique role in making your computer work. So you see, without hardware, a computer is just an empty shell. Now that we have our bricks and cement, we need a blueprint. That's where software comes in. Picture software as the mastermind behind the scenes, guiding the actions of the hardware, the tangible parts of a computer system. It's akin to the conductor of an orchestra, coordinating the movements of each instrument to create a harmonious performance. Software is the set of instructions that tells the hardware what to do and how to do it. It's the language that computers understand, turning our human commands into actions. Software falls into two main categories: system software and application software. System software is like the computer's operating system. Think of it as the bridge between the user and the hardware. It manages the hardware and also provides a platform for other software to run on. Examples of system software include operating systems like Windows, Linux, or macOS. Then we have application software. These are the programs that we interact with directly. They're designed to perform specific tasks for the user. Whether it's creating a document in Microsoft Word, crunching numbers in Excel, editing a photo in Photoshop, or even playing a video game, you're using application software. Software is continually evolving, changing, and improving, just like the world we live in. Developers are constantly creating new software and updating existing ones to enhance functionality, increase efficiency, and improve the user experience. But it's important to remember, software and hardware are two sides of the same coin. They work together, creating the synergy that allows us to carry out complex tasks, solve problems, and even entertain ourselves using computers. Without software, our powerful hardware is just a collection of circuits and chips with untapped potential. So, as we delve deeper into the digital age, software continues to play an increasingly crucial role. It's the driving force behind our digital experiences, enabling us to connect, create, and explore in ways that were once unimaginable. In essence, software provides the instructions that bring our hardware to life. We have our hardware and software, but what do they work on? That's right, data. Now let's dive into this essential component of our computer systems. At its core, data is information. It's a collection of facts, statistics, or details that a computer can process. It's the raw material that our hardware and software manipulate to create something meaningful. But what does data look like? How does a computer understand it? Well, data comes in many forms. It can be text, images, videos, and more. When you type a document in your word processor, you're creating text data. When you snap a picture with your smartphone, you're generating image data. When you stream a movie online, you're consuming video data. And that's just scratching the surface. There's also audio data, numerical data, geographical data, and a whole lot more. Every click you make, every site you visit, every song you stream, all of these actions produce and use data. But how does a computer system use this data? Think of it as a chef. The data are the ingredients. The software is the recipe guiding how to combine and cook these ingredients. And the hardware is our kitchen tools doing the actual cooking. But unlike a chef, a computer doesn't taste or smell its ingredients. Instead, it reads data as binary code, strings of ones and zeros. It's this language that allows our hardware and software to process data, transforming it into the information we can understand and use. Data is everywhere in our digital world. It's the content of our emails, the posts on our social media feeds, the high scores in our video games. It's the heartbeat of our modern, connected lives, and that's why data is so crucial. Without it, our computer systems would be empty shells, powerful machines with nothing to do. Our hardware and software are impressive, but they're useless without data to process. So remember this. Data isn't just numbers or files on a computer, it's the raw material of our digital lives, the fuel for our technological innovations. It's the thread that weaves together our virtual world. Data is the fuel that keeps our computer systems running. But who's driving this well-oiled machine? Who's making the decisions? Humans, of course. Indeed, the human element is the pivotal cog in the wheel of any computer system. It's the people who design the hardware, craft the software, and ultimately use these tools to create, process, and interpret data. The computer system, as sophisticated as it may be, is nothing without its human operators. Users are the ones who interact with the computer system, utilizing its capabilities to fulfill their needs. From writing an email to designing a skyscraper, users are the ones who put the hardware and software to work. They are the ones who command the computer system to execute tasks, making it an extension of their capabilities. On the other end of the spectrum, we have the technicians, the wizards behind the curtain. These are the people who design and maintain the computer systems. They are the architects of the digital world, crafting intricate hardware and software that power our daily lives. They write the codes, solder the circuits, and troubleshoot the systems, ensuring that the computer system functions smoothly. There's also a fascinating interplay between humans and the computer system. Users input commands and data into the system, which then processes this information and presents the results. Humans then interpret these results, making decisions based on the output. This dynamic interaction forms a feedback loop where humans and the computer system continuously learn and adapt from each other. Moreover, it's the humans who set the ethical and societal boundaries for computer systems. They decide how and where these systems should be deployed, ensuring that technology serves humanity and not the other way around. So while a computer system can do amazing things, it's still a tool that requires a human touch. It's the human element that breathes life into the silicon chips and lines of code, turning a collection of hardware and software into a dynamic, interactive system. The computer system, in essence, is a mirror reflecting our intelligence, creativity, and ingenuity. So we've taken a whirlwind tour of a computer system. But what did we learn? Let's take a step back and recap. We started off by understanding the role of hardware, the tangible parts of a computer system that you can touch and see. This includes your monitor, keyboard, mouse, speakers, and printers, among others. Then we moved on to software, the group of programs that make your hardware function. This is where we find our Microsoft Word, PowerPoint, Excel, and so forth. We also delved into the importance of data, which can come in various forms like images, text, and videos. And finally, we acknowledged the human element, the people who use the computer system to create better outcomes. Next time you use a computer, remember, you're not just pressing keys or moving a mouse. You're interacting with a complex system that's the result of years of technological innovation. Isn't that something?